Welcome to the Cloud Data Integration, Mapping Design and Development course. Hello, I'm Laura, and I'll be your guide through this training. Up in the right-hand corner, you'll notice a resources area. If present, these resources will supplement and support this course. At the end of the training, there is a quiz. This quiz is designed to provide direct feedback on your knowledge of the content presented. You are always welcome to go back and review any of the information presented in this course. At the end of the course, you will be presented with a survey. Your feedback is critical to the success and further improvement of our courses. Please take a moment to complete this very important step. Now, let's move on to the objectives for this course. The objectives of this course will cover the topics of CDI transformations. Transformations are used to manipulate data and apply business logic. CDI mappings. Mappings are collections of transformations that define the flow of data and logic. Templates. Templates are generic mapping outlines that are available to speed development. Welcome to the Informatica Data Management Cloud, Mappings Overview module. CDI mappings describe the data flow logic from source to target. To be a valid mapping in CDI, a mapping must have at least two transformations, a source transformation, and a target transformation. The mapping will be executed from left to right as designed. A mapping may contain one or more sources as well as one or more targets. The sources and targets can be of any type supported by IDMC connections. In between the sources and targets, one can place many different purpose-driven transformations to execute business logic. Some examples would be filtering data records from source, looking up and adding supplementary data attributes, and joining heterogeneous datasets. Let's look into more detail in the following slides. Transformations are a part of a mapping that represent the operations that you want to perform on the data. CDI has, and supports, a large number of transformation types that can be leveraged for your mapping needs. Sources and targets are transformations. They are defined by the properties of the endpoint inclusive of connection, columns, data types and more. Transformations are delineated by being either active or passive. Passive transformations are those that output the same number of rows that are input. Examples of passive transformations in CDI are the expression transformation and lookup transformation. Active transformations conduct operations on the total rows input and can output more rows, less rows, or the same amount of rows. Examples of active transformations are the aggregator transformation and joiner transformation. The Java transformation is an example of the platform being able to execute code not native to the platform. For complex functions that cannot be done efficiently natively, one can leverage Java coding. Hierarchical transformations allows for the processing of complex data sources and structures. The transformation can read hierarchical or relational input and convert it to relational, hierarchical, or flattened denormalized output. Web services transformation allows for integrating calls to an external application. One example of usage would be to take a date and order number to retrieve data from an external web database for customer order details. The functions you can leverage within mappings and transformations fall into different categories. Aggregate functions like average, count, min, max, and sum. Conversion functions to transform data using to char, to date, and to integer. String and data cleansing functions like replace, regex, substring, trim, concatenate and others. Numeric functions like floor, absolute, log, and moving average. Scientific functions like cosine, sine, and tangent. A common transformation for using most functions is the expression transformation. Most transformations that have an attribute-level expression editor will have access to functions to execute specific logic. When you create assets such as mappings, you can either create the asset from scratch or use a template. Data integration offers a variety of data manipulation templates to jumpstart your project. Templates include pre-built logic that you can use for data integration, cleansing, and warehousing tasks. The following are categories of templates to choose from. Integration. Integration template examples include augmenting data with a lookup, joining two sources with an inner join, and replicate data incrementally to a new target. Cleansing. Cleansing template examples include check source data for nulls and route valid and invalid records to different targets, and a duplication of source data based on unique identifier. Warehousing. Warehousing templates include slowly changing dimensions of type 1, Type 2, Type 3 and Type 6. Industry solutions. Industry solution templates include processing incoming HL7 messages and processing incoming X12 HIPAA messages. When you are ready, please move forward to the next section. Welcome to the Cloud Data Integration Transformations module. Cloud data integration includes a wide variety of transformations to use within mappings. In this module, you will learn about the three most common transformations: expression, lookup, and router. Each transformation has a specific usage. When creating a mapping, you leverage transformations in different permutations within the mapping to achieve a specific outcome. Each transformation has a unique set of options to configure. An expression uses functions as part of the configuration. A lookup is configured for a secondary source of data to retrieve values from. A router is configured for criteria to subset the mapping data into groups. The expression object is probably the most used of the objects within CDI. The expression object operates on the entire dataset but on a record-by-record basis. For context, a record enters the expression object, functions are performed on one or many attributes, and the newly transformed record is output. The expression object makes use of an expression editor to access CDI functions to perform on fields. Functions may be nested and combined to do more complex operations. A simple example of an expression transformation function is concatenation. Each record may have individual first name and last name attributes. The target may expect a combined name of last name, comma, space, first name. Using the expression object and concatenation function, you would create a new attribute for each record named full name with the result of concatenation populating it. A more complex example would be using a regex type function to parse a description-based field to extract out a particular string. Click the button to view the configuration steps for the concatenation example. The lookup object is used to retrieve data from a dataset that may be different from source. This is similar to a query. CDI supports many types of connections, and those connections can be used to access data via lookup. Depending on the type of dataset connection used, the property configuration may differ. Relational objects have different configuration than flat file objects. To retrieve data, you will provide a condition where an incoming field is compared to a field in the lookup dataset. You can compare multiple fields but only as in condition. Comparison operators supported are greater than, less than, greater than or equal to, less than or equal to, equals, and not equal to. You are also able to configure the fields returned from the lookup. For example, you may try to retrieve customer name, parts and country from a lookup table. You can select only these fields be returned to reduce the amount of data being processed and presented. Lookups can be cached or uncached via a simple checkbox configuration. Caching improves performance for static lookup data with lower volume. Uncached is typically used for large or changing lookup datasets. By default, a lookup is a passive object. Each record presented to a lookup object will execute the conditional lookup. If a match is found, data is returned. If a match is not found, the return is null. Downstream objects such as filters and routers can apply logic on how to handle rows that are null versus not null. Click the button to view the configuration steps for the lookup example. Step 1. Incoming fields. You will need to include the fields to be compared as inputs. In this example, we are using the cust ID field. We also rename the metadata so that it does not conflict with the cust ID field of the lookup table. Click the Step 2 button to continue. Step 2. Lookup connection. Configure the lookup object using an IDMC connection. Choose the individual table that will be leveraged. Click the Step 3 button to continue. Step 3. Lookup condition. Configure the lookup condition to compare the incoming cust ID field to that of the lookup table's cust ID field. This example is looking for exact match. Click the Step 4 button to continue. Step 4. Preview the result. Next to the Properties subtab for the selected object is a Preview subtab. Within that subtab is a button or hyperlink to allow you to run a preview. Upon selecting Run Preview, a configuration screen is presented. You can select how many rows to preview and where to execute the code. In this example, a local secure agent is chosen. Clicking Run Preview here will execute the code. The results will be displayed in the bottom pane. As you can see, there are some customer IDs that are found that return data. Some customer IDs are not found and would return nulls. Click the X icon to proceed to next section. Router object. The router transformation uses a filter condition to evaluate each row of incoming data. It is similar to a filter object but can be more efficient. The router tests for multiple conditions aligned with groups in a single pass. A filter object can only test one condition. If you need to test the same input data based on multiple conditions, use a router transformation in a mapping instead of creating multiple filter transformations to perform the same task. The conditions can be simple, such as testing for a string value. Conditions can also be complex, which allows you to use an expression editor and functions. Testing for a null value would use an isNull function. A router does not drop rows. If a row does not pass any of the conditions, it is output in a default group. As an option, if the default group is not connected to another object downstream, then the rows are dropped. A filter object will drop any row that does not pass the condition. Each group can be connected to one or more downstream objects. For example, you may route rows output from the found group to two separate targets, like a parent and child table pair. You cannot connect multiple groups to the same downstream object because the engine has generated distinct threads for the groups. The exception would be that the downstream object has multiple input groups, such as a joiner transformation. You could connect one group to the joiner master input and another group to the detail input. Click the button to view the configuration steps for the router example. Step 1. Incoming fields. You will need fields that will be evaluated in the group conditions as well as those you would pass forward. Field names need to be unique, so you may have to rename metadata to accommodate. This example shows fields coming from source and lookup returns. Metadata was renamed with prefixes for clarity. Click the Step 2 button to continue. Step 2. Create groups. Each group you create is aligned with a condition. If a row passes the condition, it is output as part of the group. Groups are not mutually exclusive. If a row passes two separate conditions, that row will be output in separate groups. Sometimes you may need the duplication and sometimes you may not. Click the Step 3 button to continue. Step 3. Group condition. Configure each group's condition. Some may be simple type, some may be complex and need the use of functions. The example shown is evaluating the lookup return for a null to indicate the row was not found. Click the Step 4 button to continue. Step 4. Preview the result. Next to the Properties subtab for the selected object is a Preview subtab. Within that subtab is a button or hyperlink to allow you to run a preview. Upon selecting Run Preview, a configuration screen is presented. You can select how many rows to preview and where to execute the code. In this example, a local secure agent is chosen. Clicking Run Preview here will execute the code. The results will be displayed in the bottom pane. As you can see, there are some rows in the found group, some rows in the not found group, and some in the USA group which may be duplicates of found or not found. Click the X icon to proceed to next section. Welcome to the Mappings module. Mapping Overview. A mapping defines reusable data flow logic that you can use in mapping tasks. Mappings are a generic representation of your business logic enacted on a dataset. Mappings follow a source-to-target flow. Mappings are not limited to single source to single target. A single source can populate many targets. Many sources could be joined and deliver data to a single target. The CDI mapping designer allows developers to quickly use transformation objects to build a logic flow. The visual nature allows quick understanding for others to view what is happening, and where. In order to support the business logic needed in a mapping, CDI supports a large number of transformations. Currently there are 35 plus specialized transformations that can be leveraged within a mapping. Maplet support. A maplet allows a developer to replicate multiple transformation object logic as a single maplet object. This reduces development time through greater reusability. Data preview allows a developer to validate logic as they build. As mappings become more complex, the data preview feature reduces errors prior to migration to production. Let's take a look at some of the more common mapping examples within CDI. A basic mapping like this one has one source and one target, with 0 or more transformations in between. This second example has two targets, and the router transformation in the middle will decide to which target the data will be written, based on the conditions you define. These targets can use different connections, so one target may write to a database, while the other writes to Amazon S3. And this third example shows a joiner joining data from two sources into one target. Like targets, sources can be of different types. The list of transformations is extensive. Expressions, lookups, joiners, and routers are most commonly used, but many more can be added. Adding cloud data quality logic in the mappings can be done by adding the CDQ transformation and specifying the CDQ function to call. You can use the functions in the transformation language to specify the business logic within the transformations. String functions, data cleansing, data type conversion, numerical functions, the list is extensive. Mappings can use parameters for connections, data values, and even transformation logic. The module parameters and dynamic mappings will cover this in detail. A new mapping begins with a single source and a single target. This is the minimum acceptable, validated mapping object for execution. Configuration will normally begin with the source. The properties section of the source transformation has a source section. This is where you will select an existing or create a new IDMC connection, the source type, the fields to introduce, an optional partitioning strategy for larger sources. Source types. Relational connection. The connection will determine the configuration properties available. If the connection is a relational source, the source type choices would be single object, multiple object, query or parameter. If the source type is a relational single object, the query options section will be enabled. You can configure a filter or sort using simple operational field comparisons or advanced IDMC expression editor functions. In addition, relational sources have access to pre- or post-SQL and SQL overrides for more complex sourcing strategies. If the source type is relational multiple objects, you would be able to leverage existing relationship joins to source the data. As an option, you could create new relationships between objects using the IDMC metadata. The relationship metadata syntax is displayed in the configuration. If the source type is relational query, you would use a basic editor to submit a standard SQL query to retrieve source data. It is recommended to use the query option for more complex strategies than shown here. It is better to use the native single or multiple object types for simple sourcing. Source types, flat file connection. If the source type is a flat file single object, the query options section will be disabled. If you need to filter data from a flat file source, you would need to use a filter or router transformation within the mapping. Notice that you can adjust the formatting options of the flat file source. This will allow you to declare options like the delimiter, escape character, auto-generate field names, or import names from a row. If the source type is file list, you can source a file where each line represents a path and file name that is local to the secure agent. This is commonly used in scenarios where a client has multiple files of the same structure that needs to be processed with the same mapping. An example would be monthly finance files. If the source type is command, this would be the command executed that generates the file list. An example would be a shell script that does a Unix ls command on a directory for all files with the suffix of txt. Targets. The target transformation is similar to the source transformation in regards to connection and type. Since this transformation object will be landing data, it is also more flexible. The incoming fields property is similar to other mid-mapping transformation objects. You can include or exclude fields from entering the target object. You can also rename the field metadata for clarity. In this example, a bulk prefix of CSV was added to the field names. Under the target property is where you select the connection, target type, and object. For both flat file and relational connections there are only two types available, single object and parameter. Target types, relational. If the target type is a relational single object, then you will see some new configuration options such as truncate table each time the mapping is executed. Operations allows you to choose how the IDMC target will treat the rows. You can choose insert, update, upsert, delete, or data-driven. Configure update columns when the target table does not contain a primary key and the mapping uses an update, upsert, or delete operation. When you select more than one update column, The mapping uses the IN operator with the update columns to identify matching rows. This option is visible when changing from insert to one of the other operations. As an advanced property, you can choose how to handle rejected rows. The checkbox for forward rejected rows will push those records to a declared reject file and directory identified below. If you do not forward rejected rows, the mapping task drops rejected rows and writes them to the session log. The field mapping property is where you would map the incoming fields to the target fields. In this example, the sources had been renamed with a prefix for clarity. Field map options allow you to choose manual, automatic, completely parameterized, or partially parameterized. Automatic. Automatically link fields with the same name. You cannot manually link fields with this option. Manual option. When mapping the fields, you can do this manually by dragging from left to right. This is done one field at a time and can supplement the manual auto map feature. The auto map feature allows for either exact match or smart map. Smart map will work for similar names like cus name and customer name. Target types, flat file. If the target type is a flat file single object, then most of the configuration is similar to relational type. Incoming fields, target fields, and field mapping will be the same as relational. One difference is the operations. There are no operation choices for flat files since every execution would land data in a file as an insert. The advanced properties are specific to flat file activities. Append. The option to append data to an existing file is available. If you run a mapping multiple times with different source data, you could keep adding data to a single target file. Header options. You can choose to not have a header row, output the field names, or use the output of the header command to generate a header. Commands. You can use operating system commands to generate a header, footer, or send the entire dataset to a command. Directory and file name. By default, these values are inherited from the target connection. Here, you have the opportunity to choose different output directory or file name. Time for an exercise. In the following lab, you will use a simulation to create a mapping that will use a lookup to evaluate if a customer has a related address record in a separate table. You will use a router to write failing records to a flat file and update successful rows back to the customer table. Click on the button to start the exercise. After you have completed the lab, please move forward to the next section.
Start with creating a new mapping. Select the basic mapping category and choose the default mapping object. Click the Create button to generate the mapping object. Click the text box and name the mapping. Click Browse to ensure that the mapping is placed in the correct project and directory. Configure the source object by clicking in the Mapping Designer. Rename the source to something more identifiable. Click the source properties to begin configuration. Configure the connection. This example is selecting a relational connection. Use Select to choose the source table from the connection. In this example, we are choosing the customer main table. Click the Preview tab. Click the Run Preview button to open the next screen. Choose a runtime environment that can execute the connection. Click the Run Preview button to execute. The preview shows records from the source table for you to confirm both a successful connection and verification of data. When ready, click on the Minimize window button to continue. Add a lookup object between the source and target by dragging it. Configure the lookup object. Click on the Incoming Fields property to declare which fields the lookup object should interact with. In this example, you will delete the current default rule and introduce a new one for specific fields. Click the action icon to the right. Click Delete Rule. Now, add a new rule by clicking the Add icon on the right. The new rule is ready to be configured. Click the Configure link. In order to add fields into the lookup object to both use and pass through, click on the fields needed. This simulation only requires you click 1 to continue. One of the source fields selected has the same name as a field in the lookup table. In order to proceed, it is necessary to rename the metadata for that field. Click on the Rename Fields tab. If renaming all fields, you would use the bulk option. This example is using individual option to rename only one field. Click on the Rename field to rename it and continue. Click OK to continue. This lookup will use the address table to compare the incoming customer ID to rows that exist with the same customer ID. Configure the lookup object similar to a source by clicking the lookup object property. Click on the Connection drop-down to choose a connection. Choose the correct relational connection. Click the Select button to find the table. This connection only has 4 tables available. Click on the address table, which is the top option. Click OK to continue. The next step is to configure the condition. For this example, we want to compare customer ID to customer ID. Click on the Lookup Condition property to create the condition. To add a condition, click the Add icon. This example is looking for records where the lookup table has a customer ID that matches a row from the source with the same customer ID. Click the drop-down box to choose. Next, we want to focus only on specific fields being returned from the lookup table. Click the Return Fields property to continue. We want to remove fields that will not be used later in the mapping. In this example, we will select the bottom 4 fields and delete them. This does not affect the underlying table in any way. Once the fields are selected, click the Delete button. Now preview the lookup. This preview will execute all upstream. As you can see, the top 3 records do not have matches. There were no corresponding records in the address table. The bottom records did have matches and return address data. This also shows how a passive object operates. All records into the transformation also output the transformation. You will use the null returns to determine routing. Click on the Restore window to continue. Add a router transformation to the mapping between the lookup and the target. By default, all output fields from the preceding object are included in the incoming fields. We will keep this and configure the router conditions. Click on the Output Groups property. Click the Add icon to add a group conditional. Rename the group to be descriptive. The group is named Address Not Found. Click the Configure link to open the expression editor. To achieve what we want, which is to detect if address customer ID is null, we want to use the isNull function. Choose the advanced option to get to the expression editor. Click Define Filter Condition button. We want to evaluate the address lookup customer ID. You can bring over the field by clicking Add to. You can find the functions by using the drop-down to change from fields to built-in function. The isNull function can be found under the test category. You can click on it to add it to the editor. Note that this will not format the function for you. You will have to readjust the function and field information manually. After adjusting the function to place the field name within the parentheses, you can click Validate to check before. Once validated, click on OK to continue. Click OK again. To close the condition, click on Preview to view the group results. The default group is showing rows that did not satisfy the other group expressions. In this case, these are rows that do have customer ID matches in the address table. Click the Address Not Found group to view the other results. Click on the Minimize window button to return to the mapping. There are 2 output groups from the router but only 1 target currently. The next steps would be to configure the existing target and then adding a secondary target connected to the other group. Click on the plus icon on the router object to view the groups and connection to target object. The first target is receiving rows from the default group. This set of data is expected to update the target with address details. After renaming the target object, click on the target property to configure appropriately. The target has been configured for a relational connection in the customer main table. Change the operation from the default of insert to update. Update columns are columns that uniquely identify rows in the target table. The mapping task uses them to update, upsert, or delete data in the target. Click the Add button to configure. The cust_ID field is selected. Click on the right arrow icon to click OK to proceed. Now, you will need to map the fields from the upstream object to the target fields. Click the field map. The field names of the target that we want to update are the same as that of the upstream fields. We will use the Auto Map feature. Click on Exact Field Name. Here you can see the mapped fields and those that did not find a match to map to. The next step is to add the second target for the second router group. Connect the Address Not Found output from the router to the new target. After the new target object is named, click on the target property to configure. The target is configured as a flat file connection. We want to deposit the rows that did not find address record data into a report file. Click on Select to configure the target file. In this example, the physical file does not exist yet. You will create the file at runtime by clicking on the option at top. The static name of invalid customer's CSV is given. Click OK to continue. For this scenario, we want to make sure that the field names are added to the flat file as a header row. Click on the Advanced section to configure. After ensuring that output field names is set for the header options, click on the Target Fields property to configure the fields to send to the flat file. Since you are creating a new file at runtime, you will see that there is no option to map fields. Your target fields will simply be what is declared in the Incoming Fields property. Click the Incoming Fields property to continue. In this example, we will keep the default of all incoming fields. Any fields that are connected to the target will be landed in the resulting file. Click the Validate button to validate the mapping. The mapping is validated and ready to be executed. Click the Save button to return to the Learning module.
Templates. Templates are pre-built mappings that allow developers to quickly use pattern flows of transformations satisfying a common data strategy. This section will highlight 3 different templates that are available within CDI. Template categories. Each template is made generic so that developers can accomplish the logic with some minor editing. These templates do employ parameters such as connections, sources, targets, and even some expressions. You will find the templates under the mapping section when creating a new asset. These templates are separated into categories: integration, cleansing, warehousing, and industry solutions. When you click on any of the 3 highlighted here, you will see an example one of these templates. After viewing each, you can click on the Continue Course button to continue the module. Integration category. One example of the integration category is the template named Join Two Sources with an inner join. This mapping and its components are fairly common. The main objects and techniques employed are identifying the sources, identifying the unique keys, sorting each dataset, configuring the joiner for an inner join. You can click on each marker for more detail. When finished, click on the X in the upper corner to return to the category selection. Cleansing category. One example of the cleansing category is the template named Check Source Data for Nulls, and route valid and invalid data to different targets. This mapping is a sequential flow of logic to test then segregate the dataset. The main objects and techniques employed are identifying the source, identifying the fields to test for null, route the dataset based on row level flag set in EXP rule. Optionally, add fields, like system date, to records before inserting to target. You can click on each marker for more detail. When finished, click on the X in the upper corner to return to the category selection. Warehousing category. One example of the warehousing category is the template named Slowly Changing Dimension Type 2. This mapping shows the implementation within CDI for this common warehousing strategy. In Type 2 Slowly Changing Dimension, For a new or changed record, a new record is added as insert to the dimension to represent the new information. The old version of the changed record is updated to reset its validity date and its status. This allows all historical information to be accurately preserved. The same target table is represented 3 times within the mapping to accommodate the 3 distinct actions. Insert a new record. Insert new version of record, and update old version of record. The main objects and techniques employed are identifying the sources for comparison, identifying the unique keys and fields to track for changes, sort the datasets, join the datasets to facilitate new or differing records and fields, compare for differences and flag for operations, filter out identical records, route the records based on operation, create a new primary key value for new inserts with a sequence generator. You can click on each marker for more detail. When finished, click on the X in the upper corner to return to the category selection. Cloud Data Integration Mapping Design and Development Summary. In this course, the following topics were covered: CDI objects including transformations and functions, CDI mappings with basic mapping architecture, and CDI pre-built mapping templates. Now, it's time for some review questions. Topics covered by the Cloud Data Integration series include Concepts and Architecture, Predefined Tasks and Mass Ingestion, Runtime Environments, Mapping Design and Development, Parameters and Dynamic Mappings, and Hierarchy Processing. There will be a comprehensive assessment at the end of the 6 courses. You must score 80% to pass the Cloud Data Integration series. Thank you for completing the Cloud Data Integration, Mapping Design and Development course. Please click the Exit button to complete this training.